All right, what is up, guys? Welcome to the Lake Electrical PCB workshop. We're going to get into what a PCB is, how to use KiCad to make a simple LED keychain PCB, and have you all design your own PCBs. Yay! Also, if you guys have any questions at any point, feel free to interrupt me, because you don't want to skip over your questions, because this gets into pretty detailed stuff. So if you feel like you're falling behind, just immediately be like, I need help, please. You know, don't be shy about it. Yeah. Okay, before we start, you guys should all have these set up and ready to go. Having a mouse is optional, but it's easier to use KiCad with one, and that's what most professional KiCad users will tell you to use. But if I'm being honest, I can use KiCad pretty well with just a trackpad, so I say like just use whatever works best for you guys. But if you do need a mouse, I do have an extra one, if you guys are wanting one. Yep. All right, let's get started. Today's focus will be on what a PCB actually is, as well as what schematics and PCB layouts are, how they get manufactured, and we'll even get to make a button LED circuit, yay! So first we're gonna get into schematics, the foundation of PCBs. A schematic is essentially the blueprint of a PCB. It's where you plan out what components your PCB needs and how each component is wired to each other. And that's it. It's like meant to be like pretty simplistic, like just like, oh, these are the components, these are the pins, this is how it's wired. The detail comes later, like in the PCB layout, but for now we're gonna focus on the schematic. Symbols in a schematic are basically your components. These are symbols for some pretty basic components. Can you guys guess what they are? Like, let's just go like left to right. You guys think that's a button?
Yeah.
Correct. All right.
It's in the
Resisting. Yeah, no, that is a resistor. Yeah. What about middle?
Wow.
It does say.
What about this one?
Power source.
I'd say
If you want to be fancy, yeah, power source. Battery.
Mhm.
What do you think this one is? No?
What?
Close. It's an integrated circuit. Is that?
I literally
oh,
still not see it.
oh, you did?
Yeah. I
Oh,
just
good
said
job.
it.
Okay, that's my bad. I didn't hear you. Sorry. Yeah. No, I just wanted to include this one just so you guys know that that is also a component symbol. It's just a more complex one. More basic components, also known as like passives, will just have like a simple like red outline in KiCad. But when you get like more like detailed like into microcontrollers and ICs and all that, you're gonna have red outline and also like filled in with yellow. I don't know why, and I don't know if that's like the rule for just more complex components, but just so you know. Yeah. Now we're gonna get into nodes and nets. The nodes basically represent the pins on your components that actually get connected. So in KiCad, anything that's like a circle with like a line intersecting it like to the middle is like so is a node. These are not nodes. I only bring that up because I remember you one time asked me if we were supposed to connect these, and you're not. But also, yeah, these are honestly just like what's the word, semantic. Like they're just there for the design. It's like because this is the button. It's supposed to represent like when you push it down, these two are getting connected by this line when it gets pushed down. But you're not actually supposed to connect them in the actual schematic editor. Just had to clarify that. But these ones are nodes. These ones are actually, you would be connecting them with traces. But this, just don't even worry about that. Yeah. Now we have nets. Nets are the physical connection made between nodes. So in KiCad, any green line in your schematic are nets. You can even connect multiple nodes, like here. So, wow. Question?
Are they called nets or traces? What's the difference?
Traces are what they're called in the PCB like layout, like when you're getting to actual PCB layout. But when you're just like making the connection, they're just nets. And these would be pads. No, wait, these would be pins. Sorry, I'm getting ahead of myself. These are the pads and pins and traces will be explained later when you get into like PCB layout. But yeah. All right. So now you know what symbols, nodes, and nets are. We're gonna play a little game. We're gonna play a little game where I'm gonna show a schematic on screen very briefly, and you guys have to guess what it is. Ready? Ready? All right. All right. What was that? I'll reveal what it is later. But yeah. Now we're gonna do it again with a different schematic, and this time it should be just a little bit easier. Ready? Okay. What do you think that was?
I mean, it kind of looked like an arrow to me. I think I saw two.
So you were able to see it more clearly than the first one. Okay, interesting, interesting. Well, guess what, guys? I lied. Those are both the exact same schematic for an LED circuit. Well, maybe not like the exact same, but as you can see, the second one is a lot more organized than the first, and what I noticed from you guys is you were able to notice more details about the second one than the first, because the second one was more organized. So if you were to make both schematics into a PCB, they would be exactly the same because the traces are still connected to the same, not the traces, sorry. The nets are still connected to the same nodes and it's like still in the same direction. It's just one is really unorganized for no reason. So yeah, they wouldn't be any different, but it's like painful to look at. And when you get into more complex PCB design in the future, if you choose to work with more PCBs in the future, you're gonna be seeing schematics like this, and you'll very much want to have good practice and organization when that time comes. Yeah?
Does VCC stand for Vancouver Community College?
No. Stands for voltage to the common collector. And it basically just like means you're like positive like power supply, like where power is like coming in. Yeah. And then ground is where it leaves, where it goes out. It goes to ground. Wow. So yeah. You should exercise good practice in your schematics. So positive supplies pointing up, ground and negative supplies going down. So if I go back, you can see here ground pointing down, negative points down, positive points up. Don't do like have it point to the side or have ground point up and positive point down. That's weird. Please don't do that. Yeah. So if they're pointing in the right direction, it makes it a lot easier to understand where power is coming from and where power is going in your circuit. So yeah. You should also label your components of their values where it's needed. So label your resistors of their resistor value, label batteries with volts, etc., etc. There's much more good practice for more complex circuits, but with the circuits that you guys are going to be making in this whole workshop, I don't think it's necessary to get into every single one that you could possibly learn, especially since like most of them won't even apply to what you guys will be making, but maybe in a future lesson during the year, hopefully, yeah. All right, you've been hearing about these all year, and now you finally get to learn what they are, like the actual PCB itself. So yeah, PCBs, also known as printed circuit boards, are thin boards with multiple components connected to each other through traces. So Reed predicted it, getting ahead of me, like it's crazy. They're the main form of boards for many electronic products. They're really, really common, and they're pretty much like what you think of when you imagine like a typical like green electronic board, though they can also be colors other than green. I think the reason that it's green is because that's like the cheapest color for to be like for the solder mask to produce. I think. The ones you guys will be making are actually going to turn out purple. I'll explain that later. And you might be wondering why PCBs are so freaking important, but like, just look how much cleaner it is. This is like before PCBs. They would just like wire things together. No foundation, no layers, nothing, just like this. And then now we have this. So I don't know if you feel hurt or even offended by the first image, but you're not alone.
Beautiful.
There's multiple layers of a PCB. Don't imagine it as like bottom, like middle, top, because it's more like the Earth. Like there's an inner layer, and then there's like the two middle layers, and then there's two outer layers. So I'm sorry if that's a weird way to describe it, but like it's like there's a middle, and then it like goes outer, like inner to outer. Yeah. So we have the core layer, which is like pretty much the base layer, like the inner fiberglass, which is like the board itself, like without like all the traces and components and all that. Then there's your copper layer, which is the conductive layer for traces and pads. So if you guys remember like nets and nodes, they would pretty much go on that layer because they need something conductive for like the electricity to go through. And then there's solder mask, which is the protective layer for the copper layer. It kind of just like goes on top and like in between traces to separate them and avoid nets being bridged together when they're not meant to be. For example, like if you have like a resistor connected to your like diode and then connected to, like if you just have those in a straight line, but then you don't have any solder mask at all, then the resistor will be connected to like all the other components, and it won't be in a straight line, which I don't know how that turned out, but I don't think that's what you guys will want. So very important. Lastly, there's your silkscreen layer, which is basically like miscellaneous, like doesn't affect the actual function. It's more of like just a layer of ink for like markings, text, like shapes, etc., etc. So like this box right here, if you were to like if you wanted to just have this like drawn out on your PCB, so you can know how you want to place your button, you can do that, and it won't affect like how the PCB like actually like works and all that. If you want to like put text, you can also do that. So yeah. We also have two different components that you can use for PCBs, through-hole technology and surface mount devices. So you guys are probably more familiar with through-hole components because we use them more like with breadboards throughout the year, that's what's nice about through-hole is you can use it on PCB and like also on a breadboard. But we're also going to talk a little bit about surface mount. Yeah, but through-hole components, basically, they just, like, the main difference is, like, through-hole has, like, these long pins coming out of it that allow you to, like, just, like, put it through any hole and then allow it to, like, be connected anywhere. You go through holes, hence the name, through-hole technology. Then we have surface mount devices, which has, like, very short pins that are meant to only be mounted to, like, the surface of the PCB. Also, hence the name, surface mount. Which one is better for this workshop? Honestly, like, which one is better in general? Honestly, depends. Because when you get into more advanced PCBs and you need room to put components on the front and back of your PCB, surface mount devices are gonna like help you a lot more, because like they won't like take up room on the back too. Like if you put it on the front, like they won't like affect like what's going on in the back, and they're smaller and generally just like they're like they're used more in more professional settings. But honestly, like they're really difficult to solder. Like I had the time of my life trying to solder a board I made recently with resistor like this small, no pins coming out. It was just painful experience. So for you guys, since you guys are like more beginners, I mean Dihan, I know you can solder, but like this was difficult. Like I struggled. So like just in terms of this workshop, I'd say we're not gonna like focus on them too much. Through hole gives you less room. So if you put something on the front, you obviously can't put anything on the back because there's pins sticking out. But they're much easier to solder and like better for prototyping. So if you want to like test out your components before putting them on a PCB, you can like put them on a breadboard and just see how that works before you actually like go to solder them on your PCB. So I would say through-hole components for this workshop is what you guys should like focus on using more in your schematics and your PCB layouts. Yeah. We also have this thing called a VIA, which stands for Vertical Interconnect Access, which you guys don't need to know what that stands for, but just if you wanted to know. It's basically just a really small hole drilled into your PCB. They're pretty much like really small holes drilled into your PCB, and you're just meant to place them all around your PCB, but like they're really small. Like you can't even place like through-hole components through them because they're not meant for that. And you might be wondering, why? Why do we need this if we're not even like putting components through it? They're actually very important. What I originally like thought about them is like, oh, they're just there for structure. Like they kind of like anchor the front and back together, which kind of, yeah, but like the main, more important reason is that like it helps electrical signals travel between different layers. So you're not gonna need them too much for like the circuit we'll be making today, but like for the circuit tomorrow, like you guys will be designing your own circuits and they might get more complex from there. So I'd say you might need these, but cause like it'll help like connect your ground planes together. So pretty important. And they can even like connect from the surface to inner layers, which if you're getting to more complex PCBs that like use more than 2 layers, that's gonna be very important. But we're not doing that for this workshop, but maybe in the future. Maybe in a future class. So yeah, now we're gonna get into how the PCB actually gets manufactured. So when you guys design your PCBs tomorrow, we'll be ordering them from a PCB manufacturer known as Oshpark. They're actually located in Oregon, Lake Oswego, Oregon, which is something I was very surprised to learn. But basically, they'll be receiving our CAD files, and then they'll send us a PCB with pads and traces and holes and all that. They won't give it to us with the components like soldered on or like to the side. That's like we would order our own components from other manufacturers that are like meant for like components, but for PCB manufacturers, they just give us the PCB itself. So yeah, and you get to solder it yourself, which is the fun part. Something interesting to note, which like what I mentioned earlier is PCBs are usually green because it's the cheapest color, but all of Oshpark's PCBs, either like mostly purple, you can order them, like I think you can order for like an extra fee, order them in black, but they don't make any green PCBs, which I think it was supposed to be like an accidental design choice they made when they first like were like getting established, and then they were like, oh, you know what, we actually really like how purple looks. We're gonna keep doing purple. So yeah, their surfaces are really easy to use. And shipping is much better than like the other manufacturers I've tried, so I'd say they're the best option for this workshop to manufacture our boards. All right, that was a lot of talking, and now you guys finally know the basics of a PCB and how to make one, and we're actually gonna get into how to design a very basic one in KiCad. First, we're gonna take a quick 20-minute lunch break, and if you don't have KiCad set up yet, now would be the time to do that. Do you guys have KiCad set up already? Did you guys watch the video? You guys watch the video?
Nope.
You didn't watch the... I pinged like 3 times.
To be fair, I did install KiCad, I think. I am like 60% sure.
If you have KiCad installed, like there's just like a few settings you should edit if you haven't done like what I said in the video, but like they're not too important. Just as long as you have it installed and you like can open it, like not open it. But yep, taking a break. Bennett, are you still there?
Of course.
You've been real quiet. How's it? Let's get started on actually making our PCB. It'll be a simple LED that you can like press to turn on with a button. We won't get to manufacturing it, but we will get to like the PCB layout design part, everything you need to know before getting started tomorrow with your actual PCBs. So you can create a new project by clicking File and then New Project, and then say you want it to be default, and then name it whatever, put it wherever, I don't care, and then yeah. And then it'll open your project, and first we're gonna open the schematic, cause that's the first step. All right, open your schematic. You're gonna start out with this beautiful blank canvas that could be literally anything. The first step, this isn't very important, but like you're gonna want to do this in the future, like just like label the details of your schematics. You're gonna like in the corner you'll see there's like a title and like all these like things to fill out, and you click it and it'll have all these categories where you could like put like comments and like a date and like revisions and all that. There's the three most important parts I'd say to like put is the issue date, which you can just click the three arrows button, and it'll just automatically input today's date. And then title would be like what the circuit is, so like keychain button LED circuit exclamation mark. For company, it would just be like what you're making it like for, or I guess I would say like use it for like who is making it, which is me. Yay. And if you click OK, it'll save all that, and then it'll be right here. So beautiful. Yeah. You guys, okay. All right. Next, we're gonna get our components, which if you click A, that'll open the directory. We can like kind of like search for symbols to like put them on your schematic. First, I want to hear from you guys what you think this schematic needs, and I'll write it down here.
Power source.
Power source.
Needs a button.
Mm-hmm.
Needs a resistor.
Let's hear from someone else.
Yeah.
It's okay, Reed.
It needs something.
Really?
Yeah.
I wonder if, the keychain button LED circuit might need an LED.
You're right.
That's shocking. It's like,
What else you guys think? What else? Missing one more thing.
Can I say it?
Sure.
Resistor.
Yay!
I was trying to think about the tons of that without using that terrible one from before. I was thinking it's like an even worse one, but
I mean, I mean, there's a couple words in these, like ohm, resistor.
yeah, okay, I guess you just said, oh my.
Don't make any resistor puns, guys.
Oh my.
Anyways,
That's good.
Ohm.
we're gonna search for our components. If you click A, it'll open like your like choosing symbol directory. So the power source would be a battery, right? So you can just search for that by typing battery. And it'll be two things, battery and battery cell. You're gonna use battery. You're gonna use a whole battery.
Can't believe you're encouraging us to commit battery. This is terrible.
We love committing battery in LEC.
Absolutely.
All right, next we're gonna search for your button, which if you just type in, buttons are known in KiCad more, they're better known as like switches. Not like a lever switch, but you're like switching from one state to another. And a button also does that, even though it's not literally a lever switch. It's still a type of switch. So you type in SW, which stands for switch, _ push, because it's a push switch. It's a button. It's a push button. Yeah, you're gonna get this. Yay. Next, we're gonna get your LED, which I think if you type in LED, you'll get it. If you type in just D by itself, you get a regular diode, but we're using an LED more specifically. So use an LED. And as you can see here, you can tell it's an LED just from the symbol, like without even like looking at the text, because there's arrows coming out of it to represent light and the flow of electricity going that way. Light emitting diode, yes. And lastly, we're gonna get a resistor, and there's two different symbols for the resistor that like are commonly used. To instill good practice in you guys, I'd say use the one that's labeled RUS. The one that's like, this is the one that's like the little zigzags. If you use the regular one, regular resistor, the default in KiCad is just a triangle, rectangle. Sorry guys. Yeah, but more, I think, like, I guess I would say they're both pretty common, but if you ask like anyone who like professionally like makes schematics, they'll be like, why aren't you using this one? So, and honestly, I think this one looks nicer, to be honest. So I'd say use this one. Yeah. Yeah. We have everything, or do we? I think you guys know how you can like wire this up pretty easily, but we're not gonna wire it in a circle. We're not.
Oh, man.
No.
Oh, I have the last one.
You're wrong. Let me show you guys how this would look if we were to actually like wire it in like in like an actual like loop, and why we don't want to do that. Even though that's literally how it would work. I'm gonna teach you guys about a thing called the ground plane. So, see, how would I wire this first of all? So you guys might think it would be like wired like this, like just in a straight circle. No? Let's not do that. But you could wire it like this, but don't.
But I could.
But don't. Guess why? There's these things, huh?
6 and 5.
There's these things when you get to this happens when you get to the actual PCB layout called the ground plane, and that's basically like anything that goes to ground. It's like it's not gonna have like just like a single trace. It's gonna have like a whole like net. I think you know this because you tried making a PCB that one time and I told you about like ground planes. But yeah, and because like ground planes are gonna like kind of like surround, like they kind of like cover the whole PCB, and wherever you're not having a trace, there's gonna be like a ground plane. And for a circuit like this, because it could just go like they're all connected to each other, like, and there's no like extra like each component doesn't have like more than two pins, so there's not really like a need for having a ground plane. But like I'm teaching you guys now because you will probably actually end up needing one a lot more when you make your like actual like more complicated PCBs tomorrow. But how you would wire it with a ground plane is you would go back here and you're gonna get your power symbols. Yeah. So search for ground by just typing GND and you get the ground arrow. Wow. And then you're gonna go back and you're gonna type VCC, which basically represents your positive ground plane. No, not positive ground plane. Sorry. It just represents your power supply. So I meant to say. But yeah, and then you'd wire it the same way. Except you wouldn't connect all these components to the battery. The battery kind of has its like own separate thing going on. But when you get to before you connect your LED to the battery, you'd actually connect it to ground, like so.
Wait, can you put the resistor before?
When you have components with like more than 2 pins, you're going to need like more like you're going to need to also connect those to ground. So you would connect like extra pins that need to be connected to ground with like these arrows. You wouldn't connect them straight to the battery. If you have so many things just going into the battery, that would just cause like that would just not be very organized. So this is a lot more cleaner to read. When you guys get into more complex circuits, it'll make sense. Trust. But yeah, you now have your schematic. Technically, not yet. We still have to decide what values we're gonna like, what components and like values we're gonna use. So your resistor. What do you guys think the value for the resistor should be?
300 ohms.
Ah.
That's around.
300. What do I have written here? That's actually close. Okay. So when you guys are like deciding like what like values you should use for your components, you should like first you should figure out like how much current you want going through, and what like, I mean like basically just Ohm's law, like just like figure out like all the other like values you have. So for example, like let's say if you wanted to use a regular coin cell battery, that would be like that's like 3 volts. So we can write here in this category we can write 3V or just 3. Actually I like to write 3V just because capital V. Yeah, but we'll be using a coin cell battery, so we'd say so coin cells are like 3 volts. So yeah, and then this is something like you would be searching up because you should always refer to the internet. But was I saying? Sorry. Next, after you have your like voltage figured out, like you should figure out how much current you want going through. So just like, you could you like. Honestly, just like search up like what components you have, like what like what's like the normal amount of current for it to be going through, which would be I think 0.02 amps for an LED is the right amount of current. So then you can use Ohm's law to calculate how much the resistor would need to be, so that's like 3 equals 0.02 times your resistor value. And I actually already have this written down, so I already know what the resistor value is, but
Is 300? No, it's not.
it's 150.
How do I type into ohms?
Wait? No, it is 150, yeah.
Go to Google,
150
my connection is
ohms.
private. Attackers may steal my information.
No.
Yikes. Hacker. This internet is not giving me. Alright.
But yeah, that's how you can like figure out what values, for example, like resistor value you want to use. So yeah.
So what value should we use? 150?
Yeah, because you have you want a current of 0.02 for your LED, and we're gonna be using coin cell batteries for 3 volts. So we do 3 divided by 0.02 to get 150 for your resistor. Yay! And then that's pretty much like the only component that we have to worry about. Like just like what our resistor value is and what our battery value is. So yeah, and then. Do you have anything else?
Well, I got 2 errors when I did that error check, but it's a
Electrical rules checker. I don't know what the button is to like enable that, but just like the keyboard button, but you can just like press that on the top and click run, and it'll basically just run, like it'll just look for like what errors are in your circuit, like in terms of like electrically, like for example, it says I have 2 errors here, and these ones you can actually just ignore. So if you like right click and click exclude violation, then it'll go away. Yay! And there are no errors. But let's say, how could I like wire this in the wrong way? Hold on. Maybe if I get rid of my battery. Well, that also doesn't. It doesn't check for all electrical errors, but it checks for some. Let's say if I
well, it's right.
Let's say if I like just didn't. Let's say I just didn't have these connected. I didn't have this LED connected to anything, and I just ran the ERC. Then it'll say, oh, you didn't connect your LED, and also you just have this net just unconnected. And if you click the error, it'll like kind of like highlight where it is. So, oh, it's really lagging now. It'll show you right here, and it'll show you right here the 2 errors. So you just connect those, and it's gone. Yay! If there are like components that you don't want to like have connected, like let's say for some reason, I don't know why, but I just didn't want to connect the end of this LED. If there's a little X button on the side, which you can also, it's Q on my keyboard, which it would be funny if it was X, but it's not. Yeah, the X symbol on the side, just click that, and it's a no connect flag, and it basically just lets you mark, like it just lets you say, hey, I don't want this to be connected, because when you get to like more like complicated components, maybe there's some pins you don't want to use, like for example on a microcontroller. Maybe you only need like 3 pins to be like programmed, but you don't really need the rest of them. So you'd say for the rest of those pins, you want to like put no connect flags to like tell the schematic editor, hey, I'm not using these. And it doesn't give you like 100 errors being like, hey, you need to connect this, why isn't this connected? Oh my gosh, I'm freaking out. Yeah. So you can go back to connecting those because we will actually have those connected. Yeah. And then, yeah, that's pretty much it. There's one last step to do for the schematic, and then we can get into the PCB editor, which is assigning footprints, which is this symbol right here.
Assigning footprints. Hold up.
Yes. No, not that kind of footprints. My question.
Can you get Rocket League in Steam now?
Yeah, I thought you could, but you can't.
Julia, what is it wasn't on there last time I checked.
Huh? Amp?
Okay.
Oh, it's a custom footprint I made. Oh my god, I do not want it. I hope I don't have to ever teach you guys how to make custom footprints, because that was like that was like the end of me, like my demise. Try closing and opening it again.
Anyway.
All right. footprint assignments. We're gonna assign, basically a footprint is like kind of like the physical, not physical component, but like the physical component comes when you actually like get into like the PCB layout, but it's like what like actual like manufacturer's component are you gonna like use for, like, let's say for your battery you want to use it's a coin cell, so we'd go here, click on the side, like look for battery. You gotta like click the first one and then click battery, and then let's say let's go for like a common one, like CR2032, which is, the names are like definitely like a bit complicated to understand. Like you're gonna have to like, if you have a specific like footprint in mind, I'd say like the strategy to like look for that in KiCad is like just like search it up and then see like what footprint name it uses in KiCad. Sometimes there won't be, like, KiCad won't have that footprint, and you can either like download it and then add that footprint or make your own. Don't do that, but I had to do that for there was a PCB I was working on just like a month ago where I had to make my own footprint for the screen, the audio module, and the speaker. Yeah, it was not fun, but yeah. Anyways, yeah, so you can look for the 2032 by just like looking for, it'll be like in the beginning, like this. Yeah, like any of these three are 2032. I don't know what's the difference between each one, but if you're wanting to like see like kind of how it looks physically, you can't really see it physically, but if you like right click and then press view selected footprint, then it'll like open the footprint editor and it'll let you see like what the footprint is. And it'll just like show you like a flat like design of it. But I feel like that it helps a little bit for deciding like what footprint to use. So yeah, and you can just like click any one and it'll just like show you what it looks like. So I'd say maybe the difference between like each one of these is like this one's triangle and then this one's
It's apparently the insertion method and also the but yeah, also that, yeah, the shape.
I'd say go for the 16th battery in the list, like Keystone 1058 1 by 2032, this one right here. That one looks alright, yeah. So just double click. Don't click OK, because that just like closes the footprints without saving them. You gotta like just like double click this to say that you were using this one, and you have it. And now next we're gonna look for an LED, and I'd say, what are we doing? So this is where you get to pick whether you want a surface mount or a through hole. If you click on surface mount, you get a list of surface mount LEDs. If you want through hole, you click LED through hole. I'd say use through hole. I mean, you guys aren't gonna be like manufacturing these, so you don't have to worry about like how difficult it's gonna be to like attach these, but like I feel like it would just be like nice to like, I don't know, you guys can do whatever. It really doesn't matter, but just keep it in mind for when you actually start to design design your own PCB tomorrow, because then you will very much have to think about like, oh, how is the size of this gonna look? How are the components gonna like, are they gonna get in the way of each other? Like you will have to think about that and like take more consideration into like what footprints you're using. We would prefer if you guys like try to like save as much room as possible, make your PCB smaller, because it does cost more to have bigger PCBs. Anyways, what LED to use? As I said before, these names are difficult to read, so always refer to the footprint viewer. Oh yeah, pay attention to if it says horizontal or vertical, because like horizontal, like it'll mean like this is your PCB, and then the LED will just be like sticking out like this and then bent like that. Which, if you guys want to, like, I would say like look like if you want like the regular like LED that like goes on breadboards, like, you know, like the semi-circle shape, semi-dome, what's it called? Semi-sphere. The semi-sphere shaped LED. What's that called?
Is that, you mean like the top half of the sphere? Cut it in half?
Yeah, top half of it.
On a cylinder? Like dome?
Dome. Yeah, that's what I was looking for. Yeah, dome. So I'd say look for LED through hole. Anyways, yeah, I'd say maybe maybe go for like number 33, LED THT LED D5.0. The D stands for the D here, not in diode, Dihon. This has to do with the size. I think it's diameter. It has a diameter of 5 millimeters.
Small.
Yeah.
No,
It is. Yeah, it is. This is gonna be small, but yeah, I think let's go with that one. Why not? And then, we have a resistor. Yes. Yay! Yippee! All right. Let's go. Also a through hole for this resistor, just because. Why not? So let's look.
Is this where we decide the ohms?
No, I don't think that affects it. You can kind of just like get whatever sizing you want, and then
Oh, wait, these are like the sizes of the resistor, not the ohms.
that's just the sizes. Yeah, these aren't the ohms.
So would
you can-
have something with the same size, but with the certain ohms.
Yes. Yeah, I think you can get any of these and then get any size, any ohms.
Oh, cool.
So I'd say if you get axial, that's like the it's like the ones that we use for breadboards. And I like those, so let's go with that one. And let's say, I mean, you can pick any size. I'm gonna go with let's go with, it should not be this deep, but I don't know, I'm putting a lot of thought into it. Let's go with this one. Let's go with like a small one that's still like yeah, I don't know, I'm just like, these are just the ones I have like saved readily that I like know like will work out well. And if you don't like how you're like, when you go into the PCB layout, you can like see your schematic, you can see your layout in 3D and then see what the components actually look like, and then you can see, okay, this is too big, I don't like how this is shaped, I'm gonna go back and select another footprint. So you can kind of just like switch between the 3D editor and the footprint, and I'll show you guys how to do that in a second. But double click number 19 for resistor, and then lastly we have our switch, which is a button. So we're going to go to button switch SMD or THT. THT. It's through hole. It's a through hole, guys. Let's see. So these are very complicated, and you guys are not gonna use this. This looks painful. Oh my gosh. This looks pretty simple. Like I like to go for the ones that like have short names. Well, I mean, that's not always like the best thing to do, but like kind of like the thing that has like a simple description, like it's a button, it's through hole, it's a push button with a size of 6 millimeters. What are you guys doing?
It's number 6.7.
6.7 millimeters.
No, it's number 67.
Oh, okay. That's about. I didn't notice that. Ben, are you still there? I just have to check. All quiet on the frontal lobe. Okay.
There's something happening in the frontal lobe. There's not much up there.
Lights are on, but nobody's home. All right. Yeah. So yeah, something just like something that has like just a pretty simple name, that like you can tell, okay, it's a button and this is the size, and doesn't have like a bunch of like random odd descriptions and multiple like sizing. If you want something simple, just like shorter names, but like the names have to make sense. For example, like I don't know what the freak is going on here.
Tile 8, G, 5, 7.
I don't know, yeah. And also, I don't know why there's 5 pins on this one. I mean, I could figure it out, but I don't want to right now. We're looking for just a regular button. Just this one. Number 67. And what you're going to do, don't click OK. Don't click OK, because that's not going to save. You want to click Apply, Save Schematic, and Continue.
Can I press
Just-
like 6 times?
You can press it one time. And
2, 3, 4.
oh, that actually just unsaved it. That actually unsaved it, and it's actually going to delete your Windows OS.
Oh my, I need that.
No.
You should install
It just put it just put System 32 in the trash.
It's encouraging you to
Wait,
install
so
it.
your cancel button's on the left and your OK button's on the right. But for me, my OK button's on the left. And my cancel
Oh, that means
button's
it's
right.
fake. That means they secretly
Why,
want.
why is it like that?
No, I think it's just design. Just once you click Apply, Save Schematic, and Continue, you can press OK, and then it'll be saved. And then, once you have your footprints ready and you have your schematic and everything is fine, I think the ERC doesn't have anything to do with the ERC doesn't have anything to do with the footprints. So whether you have footprints selected or not, when you run ERC, what doesn't matter because it's not checking anything that has to do with your footprints. So you can do before or after, it doesn't matter. But yeah, we have no errors in our ERC. We have a nicely wired schematic with good organization, and let me put this in the middle just for funsies. But yeah, we have that, and we have our footprint selected. So now ready to go into the PCB editor. So you can do that by you can open it from, where's the button? Where is it? You can open it from here, like if you have like just like the main menu open, or you can press this green PCB symbol button, and that'll open it. Yay! And you're like, oh my gosh, it's blank. Why is it blank? That's scary. But no, don't worry. There's a simple button to like import your footprints into here. But first, I'm just gonna like fill out the page settings. Because why not?
That's a big number.
Are you running the DRC Redley?
I don't know.
Is this ERC or there's an ERC which is in the schematic and then a DRC which is in the PCB editor. The DRC is like design rules, which is like is everything arranged in a nice way? It doesn't check for like, I think it checks for like some like electrical rules, like for breaking, like if there's a violation in like how we're wiring it or not, or it's more about the design because that's what you're doing in the PCB layout. I'm gonna put my name here.
Would you say the schematics or the PCB is the fun part?
PCB, like wiring everything, knowing how like where everything has to connect to in more, especially more complicated circuits. Like when I was making that like really complicated like board, I did not have a fun time with the schematic. I had a more fun time like kind of like arranging everything in the PCB design, like trying to decide, oh, this should go on the front or the back, or oh, let me just do this, and then it'll solve half my problems. I don't know. It's like it's a form of it's like a form of art. Yeah, anyways, you guys all have this. So basically there's a button right here which like kind of like it's like it symbolizes the schematic. It's like schematic to like PCB, which from schematic to PCB, and that basically just means you're like updating the PCB of like everything you have in your schematic. And you should have these yeah, so just have just these options checked and then click update PCB. And if it finds any errors, it'll tell you here, like it'll say, oh, you used a footprint that if you assign the wrong footprint to a symbol, because you can do that, you can like assign like a resistor footprint to a battery. It won't give you an error in the ERC, but it will give you an error here and in the DRC. But since we did it the right way, hopefully, you guys didn't get any errors when you clicked update PCB, right? Okay. Bennett, how's it going? Is it working well? Is everything going as it's supposed to be? I think he's gone. So, Benny boy. Anyways, yeah, you'll just have them like in the corner, and then if you just click, that's what like places it down. And look at that, you have your components, so beautiful. Before we start, let's say I feel like at this stage, before you like start like kind of like moving things around and stuff, you should look at how your components look like. If you click option 3 on MacBooks or Alt 3 on Windows, it'll open the 3D viewer. What? Wait, let me see if there's a button here that like, oh yeah, here. This button right here on the top of the screen. So if you don't know if you can't figure out the keybind for it, then the button's just right here, and if you hover over it, it says 3D viewer. Oh yeah, when you open the 3D viewer, it's gonna say board outline missing or malformed, because we didn't create an actual board outline yet, but we'll get to that in a second, so don't worry about it for now. But basically you can see, oh, this is what my LED looks like, this is my button, resistor, and my battery, sorry. But yeah, like if you wanted to go back and edit your footprints, let's say I want to use a different battery footprint. So I'm gonna go back to my schematic, and I'm gonna go back to footprints, and I'm going to change. I'm gonna wait a few minutes while this loads. Okay, hold on. I'm gonna set a timer to that. But anyways, let's say I want to change. It's finally loaded. I want to change my footprint to 1060. Actually, let me like look at the footprint viewer. Yeah, let's say I want to do this one. So I'm gonna double click to have that assign that to battery, and then I'm gonna click apply save schematic and continue. Then click OK. Then go back to my PCB, And then I'm gonna re-click this update PCB from schematic button and click update PCB again. And as you can see, my button changed. My battery changed. I'm sorry. But as you can see, this is what I clicked Control Z. This is what it looks like before and like this after. But yeah, it changes. And since we have all these like, we had these options selected, it like got rid of the old one. And yeah, and it's clean and oh! You know what, maybe I don't want to use this one. Maybe I think, you know what, let's go back one more time and change the battery to what we originally had. I think I don't like how, oh, I opened the spice simulator on accident.
Ooh.
No, we're not learning this, we're not getting spicy a bit. We are not learning the spice simulator today, or ever. Anyways, yeah, Keystone 1058, if you guys need to remember. But yeah, let's change it to that one and apply save schematic, continue, okay, go back, update it one more time. Beautiful. Option 3, I love that. It's amazing. Alright, now we're going to be, you guys got that error that was like board outline missing or malformed, something like that. This one right here, right? When you open the 3D view, you get this error, right? You guys should all be getting that error. If you don't get that error, something's wrong.
Something really wrong.
You're not getting the, what?
I'm getting that error.
Oh, okay. No, if you're getting the error, that's good.
Oh.
You should be getting the error. If you weren't, I would be confused because we haven't made our board outline yet, which is why it's giving that error. So we expect that. So it's okay.
Ray tracing. Oh my god, Leva. Oh my computer. Oh
Don't
my
use,
brain.
bro.
Why's your board so big? Oh my god.
Bro, please don't blow up your computer before the day's even over. It's you're blowing up your computer for the world.
Oh, use ray tracing.
Don't blow up your computer for like it's a simple LED circuit, bro. This is not worth blowing up your computer for.
I'm using ray tracing as well. That's fine.
Where did you find that?
Cause you have like the super ultra optimized computer of all time,
I know,
bro.
it's a little buggy, but like it honestly does run just as well.
Oh my
Just, like,
god.
it's a little
Whoa,
worse.
that is ray tracing. Oh
Mm.
my computer.
Anyways,
I don't wonder, Corporal.
yeah. So we're gonna make our board outline, which basically like that just says what is the actual board. Because as you can see here, like there's no like board shape here. We just have our components. So what we're gonna do, you can see multiple layers here. These are very important. Make sure you have to pay attention very closely which layer you're on when you're doing this stuff. You make something on the wrong layer, it's all over for you, bro. Anyways, we're gonna go on the edge cuts layer. That's where we make the shape of the board. You're cutting it at the edge. Ah, sorry, I don't know why. That's not why it's called that. I have no idea what it's called that, but yeah. Anyway, just draw a rectangle, and yeah, and then.
That'd be funny and draw a circle. But the hat.
Please don't. The manufacturers like they just charge you based on the size of the PCB itself, the square areas. Anyways, yeah. If you want to be weird, you can make a circle, but I'm going to judge you in my head silently if you do that. But it's a silent judgment, so you guys shouldn't care. You guys should only care about your own opinions. Oh, I should have mentioned this. I forgot to mention it earlier. But you guys are new to KiCad, so you probably haven't noticed this yet, but like if you want to select a component, you have to drag from the bottom right, like to like be able to select the actually entire thing. Like if you try to select from like the top left or something, it doesn't sorry. I lost my train of thought. I'm so sorry. Yeah, but trying to select from the top left, like as you can see, doesn't select the whole thing. Like it selects a part of it, and it's weird. I could not tell you why KiCad doesn't let you like select from like any corner. Like it has to be the bottom right corner. Yeah. So we have our board outline. We don't have our traces to connect the board. So, I mean that's pretty easy to do. As you can see, there's like, if you look closely, you can see these blue lines in between each pin. Sorry, these would be your pins. But you can see these blue lines that like kind of like go to each pin. And basically, what we're gonna do is use that to connect each one. But don't connect the ones that have the word ground on them. Let's say GND. That's where we're gonna use the ground plane, and I'll get into what that is in a second. But
What happens if you do?
you can, but you guys should learn to use and generate a ground plane. For this one, it's not needed, but you should. You should, because when you do actually get into a use case where you have components of multiple pins that need to be connected to ground, and having so many traces connecting to ground and all that is painful. So this is better. It is.
Battery.
No.
I'm a power saving code. Do you have a cord? Because this thing has more things you can plug it into. They're like USB.
Oh, cool charger thing.
I can still have some electrical.
Anyways,
I have a C2C cable with me if you need one. Maybe, yeah, I do. And I also have a actual USB-C power brick, so you can use that to actually charge without having to.
I'd steal from there.
anyways, y'all. I don't know if this I think it's the same for all for Windows and like Linux and PC and Macs and all that, but if you click X, that's like the button to actually like make your traces, and you have to be hovering over a pad to start that. So let's start like here at VCC. Actually, first you should arrange your components around in a way that like it's like not wired weird. So for example, like this, it goes like in a circle. Look, see, it goes here, then to the button, then to resistor, then to LED, and then to ground. But don't connect anything to ground. Any pins that say ground, don't connect them yet. We'll get into connecting them in a bit, but we're gonna start with everything that's not ground. So start here at VCC, have your mouse hovering over it, click X, and then it's gonna light up. And it's gonna, oh my gosh, there's a trace, guys, look at that. It's so cool. So cool. And then it'll like highlight what pins it needs to go to. So it'll be connected to both these pins. But just for now, for what we should do is connect this pin and then connect this pin to that pin. And they'll all be connected. You could also do a thing like this, like here, let me like escape, undo. You could do this, and then do this, and then do this. But that's weird. Why would you do that? They're all going to be connected to each other anyways, so
You need
don't.
Sorry, I just spaced out. You set this, but you need one for both VCC on the button.
Yeah, how you should be doing it is connect this to here and then connect this to this. It's like I'm learning with you guys. You guys like are like just teach yourself at this point. You guys are doomed.
Uh-oh.
No. How's it going for Bennett? Let's check into Bennett. Still no response. Okay. Back to the.
I'm gonna go to his house and slap him out.
Dude, what are you talking about? I'm here.
You have not been here. We've been calling for you like the last
bro.
2 hours, bro.
Oh, my bad. Sorry, I was in the bathroom.
For how long?
A long time.
Okay, well, I'm gonna hope you got this far with your like
Oh, yeah, for sure.
Okay, we're cooked.
What do you mean?
Nothing. It's fine. Actually, okay, I'm gonna say you know what, guys? I'm gonna say don't.
It looks like they both need to be connected and all that.
It looks like, but now I'm actually
just
questioning.
checked like manually by doing a really contrived thing and only connecting the leftmost pad to that one, and it seemed that one also wanted to be connected as part of the net. So
Alright, so let's gaming time.
I don't know.
Let's hope. Anyways, connect this resistor to the diode. Yay! So fun.
This is seem fun.
Yeah. And then it's gonna say connect this ground to here. But don't do that. Don't. That's bad. Don't do that, guys. We're gonna connect it another way. But yeah, if you have everything else wired up, then you're ready to move on to the next step. Oh my gosh, did I make my... Never mind. I got scared for a second. I made my traces on the edge cuts layer, but it automatically puts them on like the copper layer, so don't even worry about that.
I know too.
Anyways,
I
guys.
made a dog.
In KiCad?
Using
I did
traces.
make a dog in Keypad.
Oh my gosh. Okay. Wait, I want to see that. Turn your computer around, bro. I'm not getting it. Bro, this is what PCB art is. Historic moment. Anyways, all right. Now we have our traces. We're going to move on to the next beautiful step, making our ground plane. A ground plane is really just like a really like it's like a big. Really. Can I echo?
No, that probably helps too.
That's Bennett. I'm just gonna lower your volume, Bennett, a little bit. Sorry.
He has headphones. Why would he don't this speaker?
I don't know. Anyways, yeah. So the ground plane is basically just like it's like basically the same thing as like a net, except it's gonna like cover the entire board.
You're trying to catch.
And when you have like circuits that have more pins that need ground, this is gonna be useful instead of like just like wiring this instead of just like wiring this to like, if you had like multiple pins all over the board and having to like make traces everywhere, that would be painful, which is why the ground plane exists. So how are you gonna make the ground plane? You're gonna, bro's not. What are y'all doing, bro?
He made a cat.
Bruh.
Guys, we need to get our ground planes. Yeah, no, it's set up to do that. I'm just adding more in the meantime.
Oh my gosh, bro. All right, so you're gonna click this button. If you hover over it, it's called drop. No, don't. We're not placing vias just yet. Almost, not yet. It's option Z for my MacBook. I don't know what it is for you weird Windows users. Sorry.
Left one anchor.
Just click this button. Draw filled zones, and then you're gonna kind of draw it around, like outside of the edge, like this rectangle. Don't draw it inside. Don't draw it on the line. You're gonna draw outside of the line. You don't have to make it super big. Just right above it. You know.
And this is on the copper layer?
Yes, on the copper layer. Make sure you're not doing it on edge cuts. Actually, it shouldn't matter, but it shouldn't matter. But actually, what will happen if you try to put it on edge cuts? Oh yeah, no, it's gonna be weird. It's gonna do some weird stuff. Don't do that.
Did my battery just go down?
Yeah, your computer's cooked.
Yo, it's plugged in there.
Anyways, yeah. So make sure you're doing it on one of the copper layers. Front copper, back copper, doesn't matter actually. But yeah, you're gonna click on the corner. Don't drag. Just like click outside of like the box on the like corner and like close, and then it's gonna open this and just select front and back copper layer. And then you want to say for the net, you're gonna say ground. The net name is ground. Then click OK. And then it'll let you draw the rest of your rectangle. You're gonna continue to draw it outside of the box. So just click each corner and draw it.
Does the shape need to like look good?
Try to have it be like a 90-degree on each corner square rectangle.
What if it's really not though?
What are you looking at? Bro, the poster is bad. I'm redesigning it, don't worry. It's too cramped. The last one had too much information.
Okay, so.
And then we printed it out like 300 times and hung it like on every. I didn't even ask people if we were allowed to like hang up posters in the hallways like in LO before we hung them up. We just hung them up. And then at Lakeridge, I think we just I remember Sophia gave them to someone and then they hung it up themselves. But I remember I hung it up myself. And then they never asked us to take it down, so.
That's good.
She's judging us. Are you judging us?
No.
Oh, I think you are.
I tried to make a feature, but I ran out of space.
So your filled zone looks filled in. My filled zone is like filled out.
What do you mean filled out?
Like it's not. It's just red.
Oh yeah, no, that's right.
Oh yeah.
You're on the right track. Try to make it 90 degrees if you can. If you need to start again,
It was a bit tricky.
if you need to start again, just like delete it and then redraw it and make sure your lines aren't tilted. Make sure they're like completely horizontal or completely completely horizontal or vertical. Yeah.
Is there any way to get Autodesking method sketching into this?
No.
Can I just? Is there a rectangle tool I can use for it?
No. I'm sorry.
Surely you can draw something. Maybe it's like a weird creature scene.
You kind of just have to learn how to be symmetrical or whatever the word is.
I've unlearned how to.
Symmetry.
I can't
Anyways,
click on it.
Once you have your outline for the zone, you're gonna click B, and that's gonna fill your zone, like this. Oh my gosh, so cool, guys.
Oh,
Wait,
okay.
what?
My filled zone has been filled.
And this is basically, you see this whole red thing, like this whole like red zone.
Yeah, it works.
Yeah, that's basically one really big ground net. It's basically like one of these traces, except really big, and it spans across the entire board. For this board, it's not needed, but I really want you guys to learn it, because you really will need it for literally anything else. We're just starting off with the easy thing, but you guys are going to get into some more difficult stuff, and you guys are going to need to know how to do this, because you will need this. Because, yeah, it just covers the entire board, so like anywhere, if there's any ground pins anywhere that need to be connected, they can easily be connected, and you don't have to have really complicated traces going all over the place.
Alright.
So,
I'm
yeah.
gonna figure out how to get my rectangular. Oh, I got it. There's a 90-degree mode.
I mean,
That is not
Oh, there is.
Perfect is right. It's
Oh, if you want to place your if you want to place components on the back of the board, you can in fact do that. If you hold on, let me like delete the zone so it's easier to see. But let's say I want to move my battery to the back of the board for some weird reason. You're gonna select your battery. You're gonna select your battery, guys, and then you're gonna click F to flip it, and it moves it to the back. Oh my gosh, where'd it go? It's on the back. If you open the 3D viewer, you can see. Sorry, guys.
Did I put it to the back popular?
Yeah, as you can see, it's gone. Where'd it go? It's on the back.
That is cool.
Yeah. This if we had surface mount devices, I would be able to illustrate this better because we could move this battery right here. And if these were surface mount devices, the pins wouldn't be here and the battery could just be right here and the board could be even more smaller. Even more save all that imagine how much space we'd save. Yeah. But anyways, how do you wire something from the front of the board to the back? How does the connection? Oh yeah, yes, sir. Yes, the via will let you connect it from the front to the back. So basically, how are you gonna do that? How? You're gonna select. This is the part that needs to be connected, right? It needs to be connected here, but what the frick? It can't go here. Actually, it can, but it's not gonna do anything because this is the red is on the front, blue's on the back. What's happening? What do we do, guys? So, anyways, you have your trace, but how do you connect it? This is how you're gonna connect it. Let me try to see it. Okay, it's Command Shift X, but I'm not doing that. I'm just gonna click the button. I thought it was V. I could have sworn it was. Oh, it's V. Okay, never mind. So I'm not tweaking. You click V. I don't know if it's V also for you guys, but you just don't click on anything on the board yet. Just click V, and then you'll see at the end of your trace is this circle, is a gray circle, and that is supposed to represent your via. So then when you place it down, it flips you to the other side. And now there's a blue line coming out of it. And that basically represents that there's a like red trace coming from your switch. And you flip to the other side. Wow. You flip to the other side and now you can just easily click on here and do that. You can also, because I just realized because these are through-hole components. So their pins already go to the back. So you can just start on the back layer and then just connect it straight to there. You don't even need vias. But if these were surface mount and you needed vias to connect them, that's how you would do that. Because these are through hole, then they can just be connected anywhere. I'm gonna move it back to the front, but I just wanted to demonstrate to you guys how we would do that if it was on the back and if we had surface mount. Yay!
I have a question.
Mm-hmm.
So I want to like move everything like more compactly. That's a touchscreen. I want to move everything like around, but it doesn't move the traces with it. Is there any way to fix that?
No. Not even like if you click D, if you click on a component, select the whole thing and then click D, it kind of lets you. It kind of moves the traces of it, but not really. It's like really, and it's in a really dumb way, you know? Like if I want to move it this way, down here, it doesn't move the trace with it. And you can see there's a green line that's basically saying, oh, this trace is intersecting. And if you try to like select it and put it there, it's gonna be like, no, we're not doing that. And it goes back to where it originally was. If it would move the trace with it, it would be nice, but it doesn't. It kind of moves it, but not really. It pretends to move it, low key. It's faking. Such a fake. It's okay. Sorry, guys. Anyways, yeah, that's how you would use vias. But we don't need them. But I just want to show you guys the beauty of vias. And we're still gonna place some vias, but not in that way. Anyways, let's redraw our ground plane. Regenerate. Yay! Now we're gonna place some regular.
How do you regenerate?
B.
Oh, thank you.
You're welcome. My throat hurts. Hold on. I've been talking too much. There's never been a situation where people want to hear me talk for this long.
What's the name?
I'm
Miss Atum?
Miss Atum. No, bruh. I told my parents I want to be a teacher, and they're like, "Why?
Say anything.
you also want to be a teacher?
Maybe.
That's cool."
But it would be like that. It would be like
Math.
Being a teacher sounds like too much effort.
I think definitely I will probably struggle a little bit, like being an actual teacher, but I don't know, like just at least right now, I really enjoy the idea of teaching. Oh, interesting. Anyways, yeah, so you have your ground plane and it's beautiful.
Yay.
And now you're gonna click the vias button and you're just gonna place them around your ground plane. And these are called standing vias. Standing vias are like when it's not like attached to like a trace, and it's just there. And it just like helps with the structure of your board and helps the ground planes be connected. And you can place them literally anywhere. You can place them where your components will go. Like you could place them here. Like doesn't matter. You can't place them on traces, of course, because that would mess it up low-key. You can't place them on pads, of course. Anywhere else is fair game.
does it matter the layer this is? I assume that.
Front or back. It's gonna go on both sides because it's vias.
I can do like fraudulent pixel art.
Anyways, once you place your vias, you're done. And if you wanna, you have to place the vias after the ground plane, or otherwise it doesn't work. Like if you zoom in on these vias really closely, you'll see that it says ground. That's how you know like they're correctly like placed standing ground vias. They're standing their ground. I love making PCB puns. I'm gonna be a great teacher. I just make PCB puns all day and I yap and, but that is actually beautiful. You know, I like that. Anyways, yeah. If you place vias before making the ground plane, then it's not gonna say ground on it, and that's how you know it's wrong. So just zoom in on one of your vias and just make sure it says that, and then that's how you can confirm that it's good. And then what else? What do we have left? We're pretty much almost done, actually. Yeah, lastly we just have once you have the vias that are standing their ground.
Paste this cat everywhere.
You can just confirm everything looks right if you just open your 3D viewer, and you can see, yes, these are tiny little holes. These are the vias, and you can see your traces. Bennett, how's it going?
Oh, it's kind of fire.
All quiet on the frontal lobe? Okay. Anyways, what else can we do? I want to teach you guys like a few more things because we have like a lot more time than I predicted. Let's say let's talk about a silk screen. Yeah, a silk screen. Go on the silk screen layer, front silk screen or back silk screen. Since everything's on the front, let's make something on the front. Let's say hi. That's it. I don't know what else to put, but like let's just say hi.
Is that T for text?
Yes, T for text right here. You place it.
That says get and move footprint. Right?
T not on your keyboard. It's like on the side here.
On the side. It's on the side.
And then you place it down and it's right here. You have it saying hi right here. And you do option 3 and look, it says hi.
So,
Yeah, anyways, yeah, so you guys you have all this, guys. It's so beautiful. What else? There's got to be something more I can teach you. Like right, DRC. Oh my gosh, how could I forget the DRC? Oh my gosh.
Derivative rule of chains?
No.
The chain.
I have no errors.
What have I done?
Maybe it's the cat. Maybe you place them too close. Dion, do you also
144 warnings.
Yeah, guys, I don't think you're supposed to make cats out of
0 warnings.
I'm gonna need to ponder this.
You guys can make PCB art, but not with vias, with silk screen. You can make images if you like. There's a specific part of KiCad. You'd have to search it up because I don't remember off the top of my head. But you can take an image and put it in the schematic. You can not the schematic editor. Sorry, it's silk screen image. Like it just takes an image and it like lets you use it as silk screen, and then you can just put it in your PCB and you can put any image. Alrighty, that's. Alright guys, guess what, guys? Your board is done, yay! You've now just made a beautiful board. Now let's, I'm gonna make sure, press save.
I'm gonna take you a photo of it. You can just use the snipping tool thing to take
I could, yeah, but now it's on my phone.
But you can.
True.
I really can. I'm gonna forget to do that.
Anyways, I'm gonna teach you guys, we have like a few more minutes, and I'm gonna actually teach you guys a few extra things.
You're gonna say DRC and then I'm gonna say.
No, we ran the DRC. But yeah, DRC basically the same thing as ERC, but with your design. And we have no errors, so It's fine.
So you're gonna calculate.
Wait,
how
do you
much
guys know what a bill of materials is?
Oh, you don't want
I
to say
think
that in front of me.
all my other.
What's wrong with bill of materials?
I had to make one for the robot
Text
cart,
me.
and
Oh.
the robot had to make it a day.
So I'm
This
gonna
one's more fun,
see-
promise.
Say a day or not. I don't
Promise.
think so.
I promise you.
I'll
As
trust
long as you get your meetings early.
Like Dihan.
Immediately. Yeah.
Dion, do you love bill of materials?
What material?
We're gonna make a bill of materials for the PCB.
We're gonna make a bomb.
No! Anyways, here's how you make your bill of materials, guys.
Yeah.
You're gonna have to, it's back in the schematic editor. Well, bill of materials for your components, because these are where your components would be. So you're gonna go back to schematic editor for your components. The bill of materials, you're gonna like say how much your components will cost.
Where's that button?
Right
Oh, wait,
here,
The bomb button.
the BOM, yes. And then you only need to have let's see. So we just need to click include reference, include value, include include footprint. Description, we don't need it. Quantity, we would need it. Group by value and group by footprint, you should have those checked. Yes. So just have these checked and then click export. And then in the directory where you have the file, where you have these schematic files and all that, you're going to have a new file called whatever your project is named .csv.
Fuck my OneDrive.
And now you're going to do it again, but with the PCB itself. So go back to your PCB editor. Where is it? Where is it? Where is it? Guys, it's somewhere here. You have to make the... I know there's a button for it here. Okay, here I found. Okay, so KiCad, you're going to click File. You have to be on the PCB editor for this.
This is the evil computer that's around.
And I know
That way.
this is Dihan's favorite thing.
I did.
Dihan's not paying attention.
Oh,
See, right?
Dihan, we're building a bomb.
I like guns more to be honest.
That's crazy. Anyways, you're gonna go to File, Fabrication Outputs, and then Gerbers. Yes. And then
Taking this in the wrong spot.
it's gonna have a lot of stuff, but honestly, you don't need to worry about it. You can just leave everything as is. Then click plot.
Yep.
Right?
Yep.
Does that work? Let's see. Hold on. Let me just actually just like really quickly check.
44 no DRC violation.
Yeah,
I think it's from the cat. Anyways, you're now gonna have all these new Gerber files. Yay!
And is that what you give to the company?
You'd put all of the new files, as well as there's this PRL and then GBR job file. Basically just put all the new files that got generated into one folder and then make a zip file from that folder. And then you'd give that compressed zip file to Oshpark, which is the PCB manufacturer. And then let's say for getting the components themselves, you'd go to like a manufacturer like Mauser Electronics and then give them your CSV, and they have a feature for like automatically reading it and then getting the components. It's a bit difficult to use, so I'd say kind of like you're gonna have to look for some of them like manually. Anyways, that's how you would make your Gerber files, and that's how you'd make your CSV for your bill of materials. And guess what, guys? That's it. That's everything. You're done.
Wait, can we just like get a job now? That's it.
Get it.
Is that more or less like all we have to do?
Yeah. But
That's everything for today.
Yeah.
We are completely finished.
The water is pretty good.
There is nothing else to do.
You know?
Thank you for the day.
Water's, you know,
You're
water
welcome.
is pretty wet, you know, so.
Alright, that's
Anyways, I'm gonna close all this. Save.
Right?
Yeah, Control S. Close this, and we are done, guys. And I'm gonna turn off the stream now. Thank you all for. Oh, hi, Aisha. Anyways, thanks for attending, guys. I'll see you all tomorrow.
Feeling for myself, I guess. But
How can it
I'll get one more.